Okay, here's a request for some homework help. And I've done the solutions and I'm just going to very quickly go through them. So if at any point you want to stop, just hit the pause and have a look at it. First one, 1h from exercise 8.8. It's function of a function. We bring the 4 down the front. We lower the power by 3 and then we times by the derivative of what's inside the bracket. Then I notice I can factorise the 6x plus 3 by pulling a 3 out. That 3 can combine with the 4 out the front and become 12. And that's how you get that answer. Next one, first of all I have to prep it, which means write it in a user-friendly way that I can do the derivative of. So the square root of 3x minus 1 would be a power of a half, but because it's 1 over that, it's minus a half. The 2, however, is not part of that square root, so it remains on the bottom. It doesn't have a negative power or a square root over it. So it's prepped, ready to go. Now we bring the minus a half down the front, lower it by 1, which becomes minus 3 on 2 for its power. We come back and multiply by the derivative of what's inside the bracket, which is 3. Now those two, you've got two 2's on the bottom, which combine to make 4 in the denominator. The minus combines with the 3 to leave a minus 3 on the top, and I've rewritten that in surd form, realising that the number on the bottom here, that's what root we're talking about, and the number on the top is what power we're talking about, which is why I have a power of 3 and a square root. Okay, next one, 1w. I've rewritten it in a user-friendly form. Then the minus 1 comes down the front, lower it by 1, multiplied by the derivative of what's inside the bracket. Now the power of minus 2 means 1 over, and it's the power of 2 is just squared. With 3, it has asked me to find the gradient function when x is 2. So I've got to find the gradient function first. So bring the 5 down the front, combines with the 2. That's 10. But then I had to multiply it by what's inside the bracket, the derivative. So that's 2x. So that 2 combines with the 5 times 2 and makes 20. And I've just brought the x out the front. It's usually tidy to do that. So I've got 20x outside of x squared minus 3 all to the power of 4. And now I want to specifically know what that is when x is 2. So we're going to substitute 2 in. And you can see I've done that and got 40. Number 4. Now y equals the square root of x minus 3. Let's make it user-friendly, so we're prepping it. So I'm going to have x minus 3 to the power of a half, because that's what square root is as a power. Bring the half down the front. Lower it by 1, which gives me minus a half as its power, and times by the derivative of what's inside the bracket, which is just 1. And so I can tidy that up, realising that a power of a half is square root, and minus means 1 over. Now it tells me that that particular gradient has a value of a half. That gradient function has a value of a half at a particular x value, which I need to find out. So let's do that. Let's put a half in instead of y dash. I'll notice that means that the square root of x minus 3, I can actually really jump to straight from here to here, because you can realise that obviously if that's going to be the same as that, then this one has to equal 1. So you can jump straight down to that line there. Square both sides, you get x minus 3 equals 1, and add 3 and you get 4. Well, that's the x coordinate. Let's go find the y coordinate, and you always substitute it back into the original to find the y coordinate. So I've done that. I've put x equals 4 into the square root of x minus 3, and when I do that I get 1. So the coordinates of n are 4, 1. Number 5, let's put it in a user-friendly name. Let's find the derivative. Let's tidy it up. Now it tells me that that actually has the same value as minus 4 on 49. So I've set that equal, and you can see that, you know, all things being equal here, that must mean that the 49 on the bottom, I can equate those denominators and say they're equal. Now when I square root both sides, The square, I'm not going to just get the positive square root of 49, there's also the negative square root of 49, which plus or minus 7. So then I have to add 1 to both sides and divide by 4. And because I've got the plus and the minus cases, if I go 1 plus 7 over 4, that's 8 over 4. And if I go 1 minus 7 over 4, that's minus 6 over 4, and I can simplify that. Hope that helps.